All right, so first things first. Who are you? What's your role? And where do you work?
Hey, Bart. Phil Trickovic. I'm the SVP and GM of Tintri, based out of South.
And Phil, what are three Kubernetes emerging tools that you're keeping an eye on?
Just three. There's a bunch. So I think generally speaking, everybody and myself are very, very tracking any kind of CSI developments, which goes into the second part to me, which is most important. We're really, really investigating this and putting a lot of wood behind this arrow of WASM, which may be a little off brand from a container perspective, but it is. That's a really, really interesting technology that we're leveraging a lot with our new offerings that we're bringing out are going to be focused on providing WebAssembly out to customers who are looking to move to that type of an architecture. Thirdly, a lot of the translators like KubeVirt, those kinds of interpreters, if you will, that are behind the scenes are developing really nicely and allowing a lot of nice data interchange between platforms. As we know, it's been a tough year for data. Accessing data and some data is being locked down and whatnot. Those KubeVirt type technologies are going to be very important going forward. So paying a lot of attention to those.
Now, one of our podcast guests, Mac, believes the designers of Kubernetes didn't set out to build an overcomplicated piece of software. It grew organically with hard-won knowledge baked into the code base. How do you view the complexity versus capability trade-off in Kubernetes?
I think it doesn't have to be complex. I think it can be. Whatever the outcome or the desired outcome will dictate how complex or not complex it's going to be, as well as the talent that you've got to understand how to deliver them as simply as possible, because it absolutely can be far more complicated than basic VM structure or basic just normal compiled applications, right? Many objects, many different variables, ways to do things. I think the goal is for it to become as transparent as possible while we're delivering these applications. So Mac's right. It wasn't set out to be complex. It's become that as the power of it has expanded into other areas that it wasn't thought of initially, just basically like any other tech, right?
And with that in mind, just a little bit of a bonus question. Talking to a lot of people for many years now about Kubernetes, and it seems there's relative consensus around that the people part of Kubernetes is much more challenging than the technical part. Do you agree or disagree with that?
100% agree. 100%. 100%. It's very difficult to find talent because it's new and it's evolved so rapidly that there aren't standards bodies. There are now, but when it started, 10, 12 years ago, it was an idea. And it's morphed into covering pretty much any app you can name outside of mainframe. And even there, you can run on a host LPAR. So it's expanded to touch every piece of the tech stack that we as a community touch. Very cool.
Our podcast guest, Molly, believes many people initially think they need their own cluster because they're scared of multi-tenancy. But they learned that the operational overhead of maintaining multiple clusters is significant. What's your experience with teams being scared of multi-tenancy versus dealing with operational overhead?
I understand why they're scared. It's been, it's, not an easy feature to deliver. However, on the right technology stacks, and blowing my horn here a little bit, it doesn't have to be complicated. Multi-tenancy's table stakes to these new methodologies. Nobody should be scared of it. Availability, RTO, RPO, all those definitions of defining an outcome are what would dictate, does it have to even be a cluster or not? Sometimes you don't need it. The application could be mobile itself, right? That's something we're really big into, is eliminating that back-end complexity so that, look, they're all ones and zeros at the end of the day. How do you most efficiently deliver them where they need to be on time and accurately compiled, right? What happens in between is a lot of, unfortunately, sometimes in our market, trying to do these advanced methodologies on well-established technologies. It's just not by nature of their design going to work. And it's like we continue as a community to try to shotgun or jam these things down to architectures that you don't need, that are expensive because that's the way we do things, right? So it's funny to us, Kubernetes and those types of deployments, these microservices are so advanced and so cool, and they're so efficient. Like what we can bring to the world in the market to deliver all this stuff we're talking about has to come via Kubernetes. It cannot come trying to do it the way we used to do things 10 years ago, which that I see we're at an inflection point. There is kind of the old going to go and the new going to win. Does the new absorb the old, vice versa, or do we just go forward and try to figure it out as we go, which is what we're doing. We can support all of the above, and I think that's going to be critical for any vendor, any manufacturer. Any innovation is going to have to be able to ingest all this historic data points and use them to produce a valuable outcome, right? Well, that's what we're not seeing today. So a huge gap in skills with that. Massive. People are worried about careers. I know there's been a lot of that in the world, in the market too, right? Pay attention to this space. Pay attention to Kubernetes. There is a massive skills gap in this that I personally don't see being filled anytime soon.
Our guest Steven appreciates that Talos Linux offers a more declarative configuration with atomic updates and other features. What are your thoughts on minimal Linux distributions for Kubernetes nodes?
I think that's critical. That's part of the problem too, right? Is if you're trying to do a standard bundle, like I don't want to use names here, but a commercially available Linux, just going to send out an ISO with all these. It's not going to work. It doesn't work like that, right? And that's where we're seeing people make mistakes of trying to do things the way we used to do them, as skinny as possible. So we're doing this now too. We're making now I'm going out on a limb here, guys. It's all roadmap stuff. But for edge processing, you're absolutely going to have this. One thing that we see with Kubernetes, with AI, with these intelligent architectures is that a lot of these things are going to happen at the edge, right? Regardless of where I or anyone else wants them to happen. To be able to action on something on a smart device on the edge is going to require a very skinny base OS that's intelligent enough to do one or two things to alert the next step. So a greatly reduced distribution is going to be required, I think, to deliver these applications out at the scale we need to deliver them to. Easier to update them as well, right?
On the subject of edge, I've interacted with folks in that community for a while, speaking to, one of the chief architects at Chick-fil-A, who's based actually not that far away from Atlanta, where KubeCon's going to be. But thinking about that, you've got a really cool tape recorder next to you. If you were to install Kubernetes on that, what would be the process? How would you do it if you had to do it? You get your dream set up, running Kubernetes at the edge for a tape recorder. First of all, explain to us a little bit about the tape recorder, how old it is, what it does, why you have it. And then if we're putting that in a Kubernetes context, how would it look?
Okay, so wow, that's interesting, man. I don't know how I'm going to squeeze a Kubernetes onto this tape. That is a Tascam 38. It's I've had it for, I don't want to say how long time. Well before the 2000s. Recently, just a couple years ago, pulled it out of storage, and it's great. It sounds amazing. It's one of the best analog tape devices that you'll get as far as the sound that it brings to the mix. So I still make music on the side to get that's my therapy, is making whatever kind of music, and I'll usually master it onto that guy there. So if I was going to do, let's see, how would I get a Kubernetes image on there? What I would do is I would put my image onto a drive. I would convert that into a MIDI stream. Via the MIDI stream, I would then convert that into a CV, CV voltage, record onto track 1. Then I would be able to mount my Kubernetes image at some point if I had to take that tape to another computer that had another Tascam 38. So it would be mobile, man. That would be going way back to kind of 70s methodologies there. Yeah, put it on tape. But that's how that would work. Yes. Maybe that's the interesting experiment. Maybe I should see if we can convert that to MIDI commands. We can make some Kubernetes music.
I think it'd be a hell of a case study, and I think people really adapt. I think people really relate to these things a lot more when they're more tangible, and with things that relate to a hobby passion project where you can see it go from place to place. Imagining the mobility of that through music that you'd be creating. But we got one more question from one of our podcast guests. So our guest Zane suggested the mentality should shift from thinking we need 1,000 GPU clusters or more chips to using existing resources more efficiently. How are you optimizing resource usage in your environment?
Wow, that's a great question. That also is at the core of our belief system, which is that we should be doing the most with what we currently have, right? If you look at processing power that's available, don't care which vendor, Intel, it doesn't matter. RISC, don't care. And honestly, I don't remember exactly, but I think we're at 1 billion ops or 80 billion ops per second on some of the latest gear, which is just unimaginable if you break that down into what's possible with that amount of clock cycles. We have to get our code more efficient to take advantage of it. So our philosophy is we're going to use ours to maximum duty cycle that's available to pass those savings on. Customers are buying ridiculous amounts of compute that you will never touch with today's methodology, just because we can't get a specific piece functioning right, or latency comes in the way, or what have you. So the more intelligent the equipment, the more intelligent your platform, which is what we do, the more you'll be able to use currently existing and sometimes even older tech that does save a lot of money. We can get a lot more out of what's there than we're squeezing right now. So that is our core philosophy. So we very much line up with that question there.
And, Kubernetes turned 10 years old last year. What should we expect in the next 10 years?
I think in the next 10 years, it's going to become more invisible. Really, if you look, what's developing now, you're starting to see a lot more management frameworks and different ways of managing containers, basically outside of even just Kubernetes, right? And I think that's going to continue to grow, and I think it's going to become it has to become far more transparent to end users and to customers, right? Deploying like a smart cam, for example, that's doing personal protective gear or monitoring for toxins in the air. This is real projects that we're working on now that are new, where you've got sensors that can sense, 0.1% of oil in the ocean. Helps prevent oil spills, right? We don't need to put a 64 core, blah, 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 to do that piece. It can be managed actually very efficiently with older tech and will perform fine. So we're looking at a lot of ways of rehashing that so we can get these benefits of all this AI tech that's coming that we can't run because the power is simply not there to do it.
Phil, what's next for you?
What's next? We're very focused on that. It's expanding the abilities of this AI, and this is where it's going to go a little science fiction, but we're working very closely with application developers, for example, to produce large behavioral models or large video models, as opposed to large language models, large data set models for these types of things where you can do predictive analysis of scenarios or of what ifs and run a lot of those at a very granular level for industrial applications. A lot of cool stuff coming. That's a lot of science fiction there, but it's all happening, and it's very, very interesting, and that's what we're 100% focused on for the next 10 years. It's all going to go back to the edge, what makes sense, right? Edge, core cloud, it's all going to be required, it's all going to be necessary, and it all should be simple.
Phil, what's the best way for people to get in touch with you?
Tintri.com, shoot me an email. I don't know if you include emails on this, or if you hit our website, you can put my title on the email there, call me. Always here, always available. Love to talk this stuff. It's fascinating tech, and we can do a lot of good in the world with it. So please do call, please reach out. Especially if anybody wants to talk about putting Kubernetes on a analog synth system.
You can definitely expect a call from me then. Phil, thanks so much for your time today. Talk to you soon.
Right.
Take care.
Thanks, guys. Appreciate it. Bye.